I don't think they really get people to do a real good checking job with a lot of these places. Although Cisco seems to still do relatively good. Avery, John,
Right here.
Nicholas,
Here.
Mark,
Here.
Isaiah, Evan, whatever, Savannah, Kevin, Casey, I don't see either. All right, who didn't I get? Avery. Is there a, I can't count, never mind. Never, no, I can count. There's 6 of y'all out there and there's 5 marked present. All right, the ones I've got marked absent. Avery, Evan,
I'm here. Yeah, there's Evan right here.
okay. Say somebody isn't matching on count here. Which is why I was do a count afterwards. Chapter 3 today, and we've only got 1 day on it. And there's a bunch of stuff in it. So I'm going to speed through a couple of things real quick, and I'm going to spend more time on the models. So I'm just going to mention this front stuff initially. They do talk briefly about rules in there, which gets into your audit rules, and then they actually talk about how's it travel across the network, about what it does as it goes across, and they talk as those messages go across that it does several things in the process. One is that the message that's being sent, and that can be a message sent by us or it can be a message from the machine. And it's actually majority of the time machine messages and not our messages. Okay, or just the machines talking back and forth to keep the network up. One of the things is that the size of the message is going to be important, and we're going to be sending bigger messages than what it can handle. So there's a limit to the packet size. So one of the things, and as we go through the models in a minute, the you'll see where this occurs, that it's going to break it down into the appropriate size. So it's going to split that message up into multiple packets according to whatever the maximum size is for that network. And those will vary. Okay? So different networks have different size packets allowed on it. Then once it does that, it is going to turn around and it's going to encapsulate it. And what it's going to do there is it's going to take that segment and then put information around it that helps it know how to get it there. So it's going to put addressing information, information about the size of the packet so that it can confirm the whole thing arrives there, etc. on it. We'll be looking at those later on, but that's encapsulation. It's actually going to encapsulate 2 times. And so it's going to put logical addressing on there, which is your IP addresses, and then it can turn around and encapsulate it again and put physical addresses onto it. And we'll look at that a little bit more as we go further along and in terms of the models. And once it's got that, it's then going to send it out there. And we're going to talk about it being sending out bit by bit at that point, but it really doesn't send it all at one time. It obviously sends all over the bits. And so it's going to send it out, and it's going to do it on a timed basis there. So your network is actually working on a clock, not the time of the day clock, but where it's clocking just like who's in installation. But you mentioned on the clock speed of your PC and stuff, similar to that, that every so many microseconds, etc., it's sending something. And so that when the signal gets to the other end, it's spaced out based on that clocking. And that just spaces things out across the network port. So you'll see on that. They mentioned there about flow control, and that just affects based on the timing. It's just a way to get it out there on it. And then if it doesn't get a response back from the other machine in enough time, it's going to have to resend it, and it's going to be a timeout on it. They talk about protocols a little bit in here. We're really going to talk about protocols a lot later as we go, and we're going to talk about protocol suites in just a second, which is where I'm going to spend time on with y'all. But with protocols, all they are is sets of rules that tells it how the communications can occur. Both ends got to be using the same protocol. There's hundreds and hundreds of protocols out there. We're going to be looking at just certain ones of them, because there's some basic ones, but then there's a bunch of others. So you're not going to learn everything about protocols. They mentioned several basic ones to you that they illustrate there to you. HTTP, Hypertext Transfer Protocol. You've all used that protocol because you're using it to do your web pages. And when you look at web pages, it's using HTTP to get those web pages to you and displayed. Okay? The web pages themselves are written in HTML, but the protocol to carry the web pages across the network is using HTTP. TCP is going to be the transport protocol which maintains our conversations between the two machines. And we're actually going to talk about another protocol that goes with that one called UDP. So that TCP should be Transfer Control Protocol. I can't remember right off what the U is in UDP, but User Datagram Protocol. Okay? The datagram protocol, I could remember, but I was trying to think, what is U? And we'll talk about the difference on those as we go further on along. And actually, once we get past this chapter, where we talk about the models here, what we're going to be doing from here on through the book is basically spending a chapter on each of the layers that we talk about in the OSI model. So that's where the next 8 chapters are going to go to. Is basically a chapter, a layer. There'll be a couple of layers combined in a chapter, and actually when we get to the network layer, it's going to be split between a couple of chapters. IP is Internet Protocol, and that you're going to be using, that one's going to be used, and that's where your addressing comes into. You remember we talked about IP addresses? That's the IP for Internet Protocol. And then Ethernet is really a wiring protocol and not a soft protocol like the others we're looking at. And so we'll be mentioning that one along the way too. But that gives us our access to the network, of the physical access. And that we're going to quite often be using Ethernet, usually using Ethernet for that, but we'll see there are some other protocols on that. Now, on the protocol suites. So there's actually a protocol suite out there of TCP/IP, which is a group of those protocols including TCP and IP, although there's a whole bunch more protocols, but they named it from that. That's going to be, so they've got a whole group of those. They mentioned to you about a number of those protocols on page 107 and 108. In the suite there, they show you layers on these things, but they're really not showing you what those layers that they're mentioning right there are yet. And actually I want to talk about OSI model before I talk about TCP/IP model, because to me, that's the way I like to do it, and I think they go sort of opposite. So they give you a list on 107 and 108 of a ton of protocols that are in the TCP/IP suite. TCP/IP protocol suite dates from the beginning of the internet. It was developed for the internet there back in '69 by DARPA. They mentioned DNS, which we've already talked about, which is part of that. Boot P they've got on the list there, but you're really not going to see Boot P used now. Boot P's been replaced out. Okay? I don't know why they've still got that one listed there, but you notice there it's been superseded by DHCP. Well, it's been superseded by something, why tell you about it. But that was a way that you had to be able to boot off of some other device. DHCP basically takes care of that one of getting your addresses, and it's similar to what we're using in a lot of rooms in this building, where we don't have physical machines in the room, but just the network computer sitting there, the little box, and that it's using a newer version of that type of approach. DHCP, they then mentioned DHCP will allow us to assign an address to the computers instead of every computer having its address statically put into it. It allows, every time you start the machine up, it goes out and gets an address off the server. And a variety of other information, but the big one is the address. SMTP, y'all all use that one, but you may not know it, but every time you send an email, that's the protocol that is used to send the email. And if you've ever gone in the setup for your email, you'll see that you have to give it an address for your SMTP server. That's where does it send it to. Okay? POP3, which is the third version of POP, Post Office Protocol, is a protocol that's used for receiving your emails. It's not one that you're using much now, but it's what used to be used. That got the email on the server, and then you had to pull it down off of the server to your machine and work with it. Okay? And you actually downloaded all your email messages onto your machine. And they were stored initially on that server and then brought down to your machine for you to work with them. You can still use POP3 to actually download the messages to your machine. What you're using today where is it on here? All right, is the next one, IMAP. I was overlooking it for some reason. Is that you're using IMAP instead today, and that's where you're working with your messages on the server, not brought down to your local machine. And that's how all of your internet email systems are working. So if you're using Google Mail, Microsoft Mail, like we're using here at the school, Yahoo Mail, whatever, you're normally using IMAP now. But it allows you to work with it from the server without having to actually download that message onto your machine and then open it. Everybody see the difference on that? That means you can work with your messages anywhere. With POP3, if you went to access your email from here and then you went home, it wouldn't have the stuff still sitting there out there on the server. You worked with it on this individual machine. So it's made email a whole lot more universal for you to work with it, that you're not stuck to a machine to work with it on it. File transfer protocol, if you're going to transfer files from one machine to another, you're going to use FTP to do that. FTP is a strange one on it, is that it's an acronym that's used for two different things. It's File Transfer Program and File Transfer Protocol. But if you go to transfer a file from one computer to another computer, you're going to use FTP to do that. So when I upload my web pages onto the server that I keep them on in Western Canada, I use FTP to upload them out there. The program I use to use the FTP program, to use the FTP protocol, is a file transfer program. Okay? Trivial file transfer program protocol is one. On file transfer protocol, it actually makes sure it's accurately received at the other end. So it continuously talks back and forth and establishes it really was received completely. Trivial FTP just throws it at the other machine and assumes it got received by the other machine. About the only times you use that one is when you're going to upload files onto your router or switch, or your configuration files, and you're directly connected into it, that you'll use FTP to transfer them across. TFTP to transfer them, because you're sitting right there at it and you know they got received. So if you're sending across the internet, TFTP is not really going to be used. HTTP already mentioned. UDP we already mentioned. TCP we already mentioned. And notice they've got these things on the layers. NAT just allows you to change addresses when it comes through the router, to change it to a different address inside your network. Y'all actually use that one without realizing it. ICMP is going to be used a lot to check to see if the other machine is there. Pings that we've already mentioned, and traceroute uses ICMP. OSPF is for the third or fourth Cisco course, and I don't remember which one it's in. I think it's in the fourth one. Along with EIGRP, that they're routing protocols. ARP is just changes IP addresses to MAC addresses. It's a translation there for us. PPP is another one that comes up later and is beyond this course. So those. All right. Standards. So that networking would work better and different type network systems could work together, they had to develop a standardized system to it. TCP/IP has been there for the internet. I guess I forgot to put my phone on vibrate. Now it is. But you have developed a number of different standards so that if you develop a protocol or you're trying to do stuff on networking, you'll be able to work with other type machines, and that it's not just your machines that will work together. Initially, places did not follow a standardized system, so your network wouldn't connect to another network. Other problem was that you had to use the same type machines on your network for them to talk with each other. So there's been a whole bunch of standards developed out there. And so there's a number of organizations that they mentioned to you have standards out there, and that we're going to talk about some of them as we go. And those protocols that we've just mentioned are all open standard protocols. There are closed standard protocols we will mention at times too that are proprietary and just belong to some group, and that they don't share them out with other groups, and that then you're limited on where you can use those. IEEE, Institute for Electrical and Electronic Engineers, has developed a lot of the wiring standards. Okay? They've also developed some of the other standards for us also. So for you to be able to call it, label it as Cat 5 wire, it should be IEEE Cat 5 wire or TIA wire, following their standard for what is Cat 5, Cat 6, whatever, which means that that wire is a certain standard to it, that it's a certain type of wire to it, and that you know is going to perform in a certain way for you. Does everybody follow on that? TIA is going to primarily be concerned with wires, because that's the normal times you're going to see TIA mentioned. You'll also see, I believe it's EIA mentioned with them too. IANA is the organization that keeps up with IP numbers out there on the internet. It was primarily a US, it was started out as a US organization and had other representatives on it, and now we've expanded it and sort of left it where the US is no longer a majority member on IANA to make it more universally recognized out there. But everybody uses it in the world, but instead of the US government having control of it, but they're still in the control, and a lot of control on it, but they no longer represent the whole majority of the controlling board. And that was where you saw in the last fall, you may have seen in the news, about claims that Obama was giving the internet away to the rest of the world. The only thing he did on it was that we opened up IANA to where the number of representatives from other parts of the world can be majority of the board. But think about it on the internet. That's not a US only product. Yes, it is. We're the ones that created the internet, but it's now a worldwide whole thing. And so as far as the addressing and the issuing addresses, that's what IANA's concerned with. And besides that, we've run out of IP version 4 addresses, and by giving it over to a majority of the others, it's not just the US's fault. You can't get whatever ISP you are or whatever, that you can't get any more addresses. It's that whole board's problem of figuring out what they're going to do as they deal with that. But as we move to IP version 6 to solve it anyway. ICANN, ICANN, they're the one that keeps up with domain names. ITU, you won't see much mentioned in the US because that's actually handles stuff in Europe. That they're primarily Europe standards for the internet. So you've got a variety of those on there. They mention a couple of others in the next few pages, and they do mention back to you about ICANN, IANA, and about a couple of others that where you can change standards out there, and that what the process to do that is. IEEE does a lot of the standardization on it. Now, if there's a standard going to be developed, they do a request for comments and send out, and that people then say about how they think that standard is. They get their chances to respond back, and then the board on it looks at those and then makes changes or whatever in developing a standard. Now the idea is that no longer do we have the problem that we used to have up through the 80s until the internet really took off and helped take the whole thing off, was if you had a network in your organization, it wouldn't connect with a network in another organization. If you had Apple computers, it used Apple standards for how it connected. And you're going to find that those generally end in the word soft. Okay? If you see something out there that's a standard that says soft, it's an Apple standard. Novell, which was the biggest one of the network organizations there for a long time, they had their own separate standards, and that you saw those out there. And if you were trying to hook an Apple network and a Novell network together, it didn't work for a long time. Novell standards tend to have X's on them. They end with the letter X. You see a standard, some protocol that ends with the letter X is probably a Novell protocol. Okay? Novell and Apple now use TCP/IP standards. Okay? Along with still using their old stuff that's available there too, but everybody's moved to using the TCP/IP because that's what the internet was built on, and now we're using the internet as our backbone to the whole thing. So IEEE developed their approach on it, and they've got a whole group of standards, and you'll see those, some things mentioned on page 117. The networking standards of IEEEs are ones that start with 802. So if you see an IEEE standard that's 802 dot something, that is a network standard. So we're going to mention some of these as we go later on along. The 802.3, you'll see that mentioned quite often because that's the Ethernet one. And that's where they've got all of their standards about what is Ethernet and how does it work at the different speeds. The original standards for working at 10 megabits per second to where you've got standards out there now for up to 10 gigabit. Okay? And I think they're working on faster than that, 40 gig if I remember right, so when they're in the process of developing standards for right at the moment. 802.11, if you buy any wireless devices, you'll see that mentioned to you. It'll say that it's 802.11 and some letter, or letters. Been a single letter now with the latest one, it's 2 letters. For the latest 2, it's 2 letters. That's AC and AD have now appeared, where you were before A, B, G, N, and now into the others. Okay? That's where all your wireless standards are, and that's why our phone will be able to connect with the school's wireless network, which are obviously probably 2 different total type brand devices. And then they got some others there that you probably aren't going to touch on. But they've got these others mentioned there that they've got groups of others, and they're still adding more on there. Because obviously, like the wireless regional area networks, that's a pretty new standard there. Now, reference models. The idea in the reference model is that if you're developing protocols or whatever, that they would work at certain levels. And by saying, all right, when we communicate with devices from one place to the other, that if we use a reference model for it, and everybody works within that reference model, it'll make protocols better able to work together. Does everybody follow on that part? So it's going to be a way to see how all kinds of things can mesh together, so that we're not having to use just one thing, and you can actually go wider. The big reference model out there for you is the OSI model. Now this gets a little confusing here with the letters I, O, and S. The OSI model is the Open System Interconnect model, but you'll see it as OSI. Okay? IEEE you'll see around on other standards out there in the world also, and obviously IEEE is also the professional organization for electronic and electrical engineers and somewhat of a union on approach 2. They've got some different groups on it. I used to be a member of the computer science group, Paul. High-level engineers all belong to IEEE. And I used to go to some meetings with them, and they talk off on some real high level out there on some stuff, but then they have some other stuff that would be fascinating to me. And then there'd be times they go way over my head. OSI, the OSI model is made by ISO, okay, which you have actually seen signs for before and mentioned in other places, nothing to do with computers, okay? It is the ISO is the International Organization for Standardization. So, I told you it's the OSI model. ISO is the acronym for the organization, but you end up with IOS is when it's spelled out. Okay? Does everybody follow on that? Now, you'll see where I'm saying ISO gets confusing. Those 3 letters. Here's the problem right here. It is the International Organization for Standardization, but they figured out early on, as far as going with an acronym for it, IOS didn't work because that gives us a chemical symbol that a bunch of people would mix up in their papers and stuff. So that's why it's ISO instead of IOS. Even though it's spelled out as IOS. Y'all follow on that? Where have y'all seen some standard of ISO? And a number of that companies a lot of times will put out in front of their plants and stuff saying that there's something about ISO. And there's a lot of plants will have a flag flying in front of their plant, ISO and this number, saying that they meet that standard. And you y'all know on that one? Quality. ISO 9000. If your company has met the ISO 9000, you can say your ISO 9000, 9001, some other numbers in the 9000 series certified, and that you've met quality standards, international standards on it. Okay? Y'all follow on that? Which just means basically that you do things like you say you're going to do them. So if you're building something, you're saying that you've got it documented, the process you do to build it, and that you follow that process. It really doesn't say that your product's a whole lot better than somebody else's, but that you consistently follow the process that you've documented for how you do it. Does that make sense? So that makes it quality anyway, that it's consistent. But you'll see that one out there, the 9000. And the 9000 series is their series for quality standards. There's other ISO standards for all kinds of stuff out there also, okay? The one we're concerned about is the OSI model, which they developed. Now I say the big thing on that, just starting right off, is getting our I's and S's and O's straight. Okay? There's 7 layers to the OSI model. See, if I'm not careful, I'll mix my letters up too. And this is really the backbone for how networking is done, off of the OSI model. There's also the approach, I'll say, where the book's going to go to from here through the book, and I gotta remember the order this book goes in. So that we're gonna work on through the book from the bottom layer up. When we get to chapter 11, we'll finish the top layers. When we start in chapter 4, we're gonna start with the bottom layer. So we're gonna spend an entire chapter or more, or approximate, in the case of layer 3, we're going to spend 2 chapters on it. The top layers, we're going to actually combine them in 1 chapter. So we'll cover all 7 layers in the remaining 8 chapters. And that's going to be the approach of the book. With the OSI layer, and you've got to know this one, okay? You're going to have the working up from the bottom layer. We've got the physical layer, and I'll talk about these in just a second. Let's walk the 7 layers up. The data link layer, and I'm going to give you some help on that. Network layer, transport layer, session layer, presentation layer, and the application layer. And you need to know all 7 layers in order. There's some different mnemonics out there that you can use to remember on them. The one that I remember the 7 layers off of is working from the bottom up. Is programmers do not throw sausage pizza away. Okay? I think the book throws you a different one that works slightly different on. That having worked with programmers in a big programming organization and being around a lot of other programmers, that would make sense to me, because a lot of them, you give them the assignment and they go hide away in the basement or back in their cubicle, and you slide pizza under the door, and every few weeks you send somebody in a hazmat fit suit and get pizza boxes and the leftover slices of pizza out of their cubicle and trash it. So that works on that. Whatever you can remember on. My suggestion to you when you take the test, and if you go take a networking certification test, first thing, write down those 7 letters in order, so that you'll remember which one's which. They're numbered from the bottom, so this is layer 1, 2, 3, 4, 5, 6, 7. So if they say something about the 3rd layer, which I just said a few minutes ago, because I said this 3rd layer we're going to spend 2 chapters on. Okay? You need to know what layer the 3rd layer is, or the 5th layer, or what layer is below the network, or the layer that's above it. So here's what's going to happen in here. Information's going to come over to the network, and your network card is going to handle this part. Is that it's going to go from the application layer down to the physical layer, and at that point it gets on the wire and gets transferred to the other machine. It then goes through the same process, working through there, and then it gets handed off to the program. And either the program does something with it, or the user does something with it, and the program has it and gives it to them. Okay? You make a request up here in your browser. You use HTTP, so it passes it to here with HTTP, passes it down, passes it across, comes back up. The web server gets it up here, looks at what page you're asking for, sends back the page, coming back down the same way, it comes back up, it gets handed off to your browser, and your browser displays the web page on your screen. To put it real simple right there. Does everybody follow on that? Now, all you've thought about before today is you're sitting there at the browser, you punch in whitebot.com, and lo and behold, you know it goes over to the server, so you thought it just went to the server then just shot it right back in. It actually went through all 14 of those layers. Y'all follow on that? Now, let's look at these layers. The physical layer is concerned with actually putting the information on the wire. I'm using wire in the broad sense when I normally say wire in here. Times where we literally do mean it by wire, but normally wire means, could be wire, it could be fiber, it could be air or wireless, okay? But we'll talk about it as wire in a general sense on that. So that puts it onto the physical medium, okay? That actually sends it across, and notice that's when I said it actually gets sent to the other machine, okay? Could go through a number of machines along the way going there, passing through a number of routers to get all the way to that location, okay? And that's what we'll spend time talking about on that. But its concern is to put it out there on the actual wire. It's going to be working with it on a bit-by-bit basis, okay? Your router is not going to be there. Your network card is there. If you had hubs, which you shouldn't anymore, they would be on this layer also. But that's actually putting it out there, and that your wire is sitting there too. But your network card is the big one as far as the device at that point, because you're actually putting it out at that point. The data link layer is going to be dealing with frames. It's also dealing with MAC addresses. On the data link layer, that's when it gets put on there, and this is working from the top down. I really should have worked the other direction. But it's going to create frames at that layer. It's either going to create a frame when it's sending it out, or on the incoming side, it looks at the frame, that because this layer brought it in bit by bit and put it all back together into a frame. It passes it up to the data link layer. The data link layer looks at it as a frame and says, okay, I see the physical addresses on there. Does it belong here? Based on that physical address. Is the physical address match? And that at this point, as far as devices, you're working with switches here. So it's getting it to the correct device. Okay? The network layer is going to be working with packets. And this is the layer you do the most work with. And of course I forget packets for a second there. Because you're going to have packets on this layer. When it finishes with that frame, it has disassembled the frame, but it hasn't looked at the data in there. The data's still in a packet in there, which has got other stuff built in it. And we'll be looking at the frames and the packets when we get to those particular chapters. But in the packet, it's got our logical addresses. And on this layer is the routers. We'll turn around and go back down this thing and maybe make some more sense to you in a second. Transport layer is where our segments are. You remember when I first started this whole lecture, I said about one thing that happens is, the first thing's involved is it breaks it down into usable sizes of whatever the maximum size that you can send it across in pieces across the network. That's a segment. Y'all follow on that? So likewise, if you want to ship something through the Postal Service or UPS or whoever, or FedEx, there is a limit that they have on you on the size of the package that you can send through those shipping services. Y'all follow on that? Even if it's really big and you get a tractor trailer to it, you're still limited on the size of what you can send. Okay? If it's something that's bigger than that, then what the size limit is, what do? You can take it apart and send it in multiple packages. Everybody follow on that? So if we got something bigger to send, and the post office will let us send, or UPS will let us send, we can break it apart and make it into smaller pieces, send it, and what's the job at the other end of who you are sending it to is going to be the job to do then. Put those packages all back together and they've got what we meant to send them in the first place, right? And you do that occasionally, that you've got more stuff than you to send to somebody than what the size is allowed to send. It might be actually physically take something apart, or it might be just package it in multiple packages. The session layer, so from here down, we're actually dealing with how are we dealing with the data and getting it into the way out. The session layer's primary responsibility is just to establish communication with the other end and make sure the conversation stays there. Another one to think about this one is, which made sense to me when I was learning this, is to think about it as a secretary. It establishes the communication with the other end. Now, in some cases, we send stuff out there blindly, like radio stations and TV stations, and just trust it gets sent, that it gets received by the other end. Just think about it. Radio TV station has no idea whether anybody really gets what they're broadcasting out there or not. They just bounce it out in the air and hope people are receiving it, right? No confirmation on it, okay? That's where we mentioned about UDP, which actually comes down on this layer, that's been out there. But other stuff, we want to make sure it really is received. If I'm in a telephone conversation with you, we make sure that the other one heard it, right? So if I start talking to him on the telephone and I tell him something, he confirms back to me he heard from me, right? Or if he didn't understand me, he'll tell me that he's not understanding what I'm telling him, or their telephone call is getting messed up. It's confirmed on it, and when we hang up, I know he got whatever I was telling him. But if I go out to the radio station and broadcast, I don't know whether he heard me or not. The only hope on that is radio services give us some idea on that. So thinking of it as a secretary may well be a way on it, because if he and I are both high-level executives, okay, if I need to call him, am I going to pick up the phone and call him if he's president of some big international company and I'm president of some big international company? Not really. What am I going to do? He's my secretary. I'm going to call him, tell him to call him to set up a phone call, and who's he going to talk to when he calls him? Not him, but his secretary. Now you're a secretary. Okay? The two of them as secretaries are going to establish, he's going to establish that he's really there. But maybe he's not there if he can take a call now. And once they both establish that both of us are available to talk to each other, then they pass it off to us, and we have our telephone call. Y'all follow on that? Odds are, when we reach the end of our call, we may well pass it back to our secretaries again. That we've said, okay, we're going to do such and such, or meet up at a certain time, or have lunch on a certain day, is our plan. But we really don't know if we are available that day or not, and give it back to our secretaries, get on our schedule, and establish that it really will work for us to do whenever. So, everybody follow on that? And then they disconnect the ultimate call. That's what the session we're doing. But the two of them as secretaries were not involved in what the material of the conversation was. Follow on that? Isaiah and I were involved on that part. We talked about what we really want to talk about. But the details of it, we left to them. And for them establishing the call and ending the call on it. That's what session does. The secretary is a good little synonym there. You just put the both start with S. Okay? So you can help on remembering that one. Presentation layer, in the going down approach on it, what it does is it takes the information we're wanting to send across and changes it into a format that the network will understand. So all its job is to get it into a format for the network. To change it into a code it understands. The application layer works with our actual application and getting it into for the network. And when it comes back up, of taking it from what's been sent across the network and getting it into a format and knowing which application it belongs to and handing it off to that application. But the application itself that we're using is not on the application layer. That's above and separate. Because this is just the network portion. So everybody following that? And so that's why I drew the browser off separate from here, not down beside the application layer. So we're going to send some. John decides that he wants to send a message to Savannah. Okay? He types it into his email program and hits send. So far, all of that's just on the computer, and that's just computer stuff on it. He hits send, it transfers it to the application layer. The application layer says, okay, this came from this email program within the browser. What browser are we using? That it's using HTTP. And it puts that information on there to send it. Because that's going to be critical when it gets to the other end. It's going to need to know what program did it come from. So it knows what program to work with. It passes it down to the presentation layer, which then turns it, takes that data and puts it in a format that the network will understand. It puts it in our networkable format. The presentation layer passes it down to the session, and basically the session looks and sees if we're sending it where we're going to have confirmation on it, it makes sure the other machine is available, that it really does exist. Okay? While we're doing all of this, once it establishes that, if it's one where we do confirm of everything, the session layer continues to make sure everything's going across and getting received by the other end. In some cases, it doesn't play anything else in it. In a lot of cases, it doesn't. It just gets sent, and we trust it got received. It gets passed down to the transport layer, which takes that whole big chunk of data that John was going to send to Savannah, and it's way bigger than our network can handle, and it breaks it down into smaller pieces, whatever size our network can handle. Does everybody follow on that? Which there's sizes on that. 1,500, I believe, is the size that normally most of them are using, but networks can have bigger or smaller segment limits. It gets passed down, that segment then gets passed down to the transport layer, which puts on it, looks at it and says, okay, we're wanting to go to that address out there, and that he had put Savannah at gmail.com. Okay? Well, that means it's got to go to Gmail, so then it looks up out there to see what is the IP address for Gmail and puts it onto it as a logical address, the IP address for Gmail. Y'all follow on that? Also looks at the data of that segment, sees how long it is, puts that onto the packet. When it segmentized it, it numbered all the segments also. Because the order they may get there in may not be in the order that we created them. On some protocols, it will be exactly in order, but in most cases, it may show up in a variety of order, and then it's got to put it all back together. And the router is the one primarily concerned with it at this point. It then passes it down to the data link layer. It takes that packet and turns it into a frame. What it does is it then looks and sees what's the actual address it goes to next as it goes across. Because remember down here, it didn't go straight from this machine to this machine. It actually passes through a number of routers. It may go straight between them, but normally it's not. It's going to pass through a number of routers to get to the other end, okay, as it goes across the internet. What it's going to put on here, when it put the address on here, is actually the address on this other end. When it puts the address on here, the physical or MAC address, it's going to give what's the next router it's going to hit on the way to getting there. Okay, because it really doesn't know exactly what the whole path is, as it starts out from the beginning here of what the whole path is to get to this other end. It just knows where's the next spot to go. That's then going to decide what's the next best spot to go to get to where it's finally going. It's sort of like we decide that we're going to take a field trip to Los Angeles today. Okay? We don't get out a road map or anything and plan this whole thing. We don't use MapQuest or Google or GPS to do it. We're just going to do this blindly. Okay? And we're going to go to Los Angeles. We know that's west of here, and we know interstates will get us there, right? So from here, we may go, okay, we know that much information about how to get there. So we're going to go to Chattanooga and ask somebody there of how to get to Los Angeles. And they're going to look at us and go, well, if y'all will just catch 24 on out and head on out, and you can go to Nashville from there, and somebody in Nashville is going to know better about how to go from there. And we'll stop in Nashville and ask them, how do we get to Los Angeles? And they go, well, I know you go to Memphis to get there. Okay? So we'll head from there to Memphis, and so on across the country. Y'all follow on that? Each time stopping at that next location, and ultimately we will get to Los Angeles, right? Now we may take a long route to get there, but somebody may send us off going northward, because the only way they know about getting to Los Angeles was that it's west of Chicago, so they send us off towards Chicago to get there, okay? Instead of staying on 43rd and 20, going on along to get there, okay? Y'all follow how that works? Likewise, you mail something at the post office. It actually follows the same approach. You stick it in an envelope. You've actually put a logical address and a physical address on that envelope. You've told it the name of the person it belongs to. That's a logical address. The physical address is where you told it the street name and the number and the city that it belongs in. Okay? So you have put a physical address on that envelope and a logical address. Because it can change names of people that live in houses or whatever, right? And then when you mail it, it doesn't just go straight to that post office. What happens in the post office? They look at it and go, does it belong with our post office? Or if it doesn't, they throw it in the cart that says take it to Chattanooga. And they'll sort it there, look at wherever it's going to, and go, what's the next regional post office on the way, and they send that whole cart of stuff that they threw in there to that one that then sorts it and sends it on to the next one. It's in carts at that point that are labeled according to which post office it belongs to next. So it has actually been packaged into a bigger package, just like I'm saying these are packaged. Y'all follow? And ultimately it gets to the end, they get it and they open up the envelope. And if it was something we had to split in multiple parts, they put it all back together. When it gets passed down to here, it actually puts it on the wire and sends it. Okay? Now, as it comes along here, when it hits this router, it comes to here, it actually passes back up to layer 3 on the router and looks at what the IP address is and determines what best and repackages and sends it back down. It doesn't always work all 7 layers. It may work just a couple of layers, going back up and then come back down and be repackaged. Y'all get a little of the idea of how this process works? Okay? And when I say we're going to go into details as we go on through the book about how this stuff works. I want you to get the general ideas on that. Okay, but it is the 7 layers on it. It is similar. If nowadays, agreed, we're going to use GPS and we're going to use Google Maps and MapQuest or whatever and have the whole trip plotted out. But think back before those. And a few of you can think on that because John can think on how to travel without GPS. Although we sit there and go, how did we do that? Okay? Some of you in here, you're going, you mean you used to actually travel places without a GPS that told you exactly how to get there? That we went by signs going down the road and took our best bets and sometimes took a long way to get someplace. And even Google Maps and GPS and stuff don't always send you the shortest route to get to someplace either. Okay? So you still have to use a little intelligence on it sometimes to figure out there's a better way to get there. The first time I came up here from South Georgia to have my interview over there in Rock Spring, the way that I was sent by whichever mapping program I used on the internet to figure out where Rock Spring was, sent me all the way up here to our exit, past the school right here, and down, and sent me across the country to get down there to Rock Spring, which requires a couple of turns if you've gone from this campus to the other campus, and got me there. Except for the fact I missed a turn along the way, that I thought I'd missed a turn. I may have missed a turn, I made a wrong turn, but I ended up back on the correct road. And I got down there at K. Conway in US 27, and I'm going, I'm not sure if I'm where I'm supposed to be or not. And then trying to find a school from that spot, I drove up to Chickamauga, drove down to Wanda's Restaurant, didn't quite make it down to the school, thought I'd go too far. I thought that was the edge of Rock Spring. And drove back and forth 1 or 2 times, and then drove a little bit further past Wanda's the second time after I'd been to Chickamauga and back, and realized that that didn't work, and found the school. Well, then when I physically looked at a map, I went, why did it send me all the way to Ringgold, go to Rock Spring? Then a whole lot easier if it just sent me across 136 and then up 27, and been much more direct on it. But the mapping software didn't seem to realize 136 would take you basically straight across. So don't fully trust them. The GPS, don't always trust it either. If I'm going to Greenville, South Carolina from here, my GPS for some reason on an exit on I-85 in Georgia says get off on the exit, turn right, and a third of a mile down the road says make a U-turn. Make a U-turn because I got off one day just to see what in the world was this thing talking about when we get to there about wanting me to exit. But I went, I'm going to see if it's got another road for me to go to Greenville. Make a U-turn and immediately put me back onto the interstate. For some reason, it did not want me to take that bridge going across that road. It was the only thing I could conclude, is that apparently my GPS thinks that's a bad bridge. or other GPS units like it have been in wrecks, and it notes that and it says, I don't want to take a chance on a wreck on this bridge. So they will lead you off strange at times, okay? There are other times that you'll go, I know a better way to get there than what GPS is telling me. So it goes back up and follows the same thing going back up at the very end and ends up handing it off to whatever the program is. We're going to have port numbers involved with our IP addresses that will tell it what's the application it belongs to. Okay? Y'all get the general idea of the OSI model now? So I knew that's where we're going to spend most of the time. Now, TCP/IP model. So there's a second model here. So that's OSI. TCP/IP model. Besides it being a group of a protocol, besides it being a suite of protocols, they also developed a model themselves at about the same time as the OSI model was developed. They were both being developed separately. TCP/IP one by the people that had done the internet, by DARPA and them, and coming up with a model of how they saw it all working together to do. About the same time OSI was, and this is back about 1980, okay? To get, so that then you could get various type protocols to work together by, all right, if we've got a model of how this all works, then you could use a different protocol to communicate in there and then work to get those protocols standardized and be able to recognize each other. Because if you go back to the 80s with the beginnings of networking, you had a bunch of different type networks out there that did not work together at all and all worked differently. I've mentioned Novell to you. I've mentioned to you that Apple had their own networking standards. The internet had its own, but the internet wasn't really a network of networks at that point other than school networks and government networks, but as far as small networks and organizations or a company's network, they didn't go get out onto those generally. So they used different standards for it all. Lantastic was one that I used for a while that I installed at several companies. There was Vines out there. There were several others, and I can't even think of the name of some of the other names. But I used Lantastic several times, so that's why I can remember that one. I still got the software for it and the book for it. Vines, I went to training for that one a few times. Seems like there was Banyan, and I don't remember what else. Any of you from back there in the 80s might remember something that we used in the process. But Novell was the big one back then, and Apple had their own for their own stuff. So TCP/IP came up with using their protocols, what their model was going to be. They came up with a 4-layer protocol. Okay, so it's only got 4 layers instead of 7 layers. So you're going to know these 2. So there is the application layer. Transport layer. Internet layer. And the network access layer. Did I get those right, John?
I think so.
He handed me notes that y'all got, there's an error in the online curriculum.
But then I did it here and it was right, so I
It's
did.
right.
I don't know if my browser's mixing it up or what, so I'm gonna, either they corrected or
Okay.
my browser's messing it up.
This one, you'll quite often not even see the word access on it, but you'll just see people say network. Some of this is easy comparing to this one, and one point is confusing. The application layer here basically corresponds to the top 3 layers on here. So that what they did in TCP/IP, they saw what all occurs on this as just being one layer of stuff. Okay? The book's going to somewhat take it of that approach too, because we're actually going to cover these together in one chapter. Okay? There's not much difference between the different layers on it, and it does fit well together. So TCP/IP just went, this is stuff really dealing with getting it to work with the application. Where this broke it down and said, this works with the application, this deals with how do we get the data to give it for the application to be able to then handle, or taking it from the application for the network to handle, to get it into the appropriate ways. It's not presentation as putting it on the screen, but how it does that either the network or the application know to work with it, to put it in a format it understands. That's not into human application or presentation on it. And then session right there. This is the easy one. Transport layer is the transport layer, and no matter which model you use, it does the same thing on both sides, called the same thing. Everybody follow on that? That one you can remember. The network layer on the OSI matches to the internet layer on TCP/IP. This was written in terms of general networks. This was developed by the people that developed the internet. We said on here we were putting IP addresses on there, which is internet addresses, right? So they called it the internet layer. So they weren't thinking internet specifically, they were just thinking network connecting to networks. They called it network. Now, this is where it gets confusing. They called this bottom layer, because they saw it as putting it onto the individual network instead of the overall big thing. They called it network, which matches to these 2 layers, which is getting into how do we actually physically get it out there. This layer here, I didn't mention this on it, and I'm going to go ahead and mention it now. This layer here actually has 2 sublayers to it. It's the only layer that has sublayers. The difference between these 2 is the one that's at the top deals with software-oriented stuff, and the bottom one, which is the Mac sublayer, I can't remember the top sublayer at the moment. It deals with physical type stuff. It's actually dealing with putting the physical address on there and that type of stuff. So that layer actually deals both software and physical, and so it's got 2 sublayers to it. So the network access layer corresponds to these bottom 2 layers. Did you find it out there, John?
Logical link.
Logical link, correct. And I should, which associates back to our logical addresses on the layer above. Okay? I got too much information I try to carry around my head. Because if y'all notice, I've been doing this whole lecture with no book. Okay? So there's the 4 layers on this. Similarity between the 2, doing the same type stuff, but presented in a different format. Okay? They're more concerned with it from the internet approach. This is more concerned with the individual networks approach to it. Okay? Was the original design, but both end up covering the same thing for us. This is the one that you most normally see people reference as a reference model. When people talk about layers and the reference model out there, this is what they're usually talking about. Mnemonic for remembering on this one, I really haven't ever seen any books for it. Everybody seems to think you can remember 4 layers with no problem. And I know y'all are all highly intelligent, as am I. But I trying to remember 4 layers and 7 layers off those names there can get confusing. This is the one I came up with this. Actually, when I took the first Cisco class, when I took the class you're taking, so I had to take these classes to be able to teach them. I had trained as an instructor at that point. I had to sit up at the University of West Virginia for a week and do everything you're doing in 15 weeks, that we were there 8 hours a day. Actually 6 days of it. My instructor told us on that one that used his name in it. And he said, but I really don't know anything to tell you to tell your students. But it would work for those of us that knew him. And his name happened to be Art Tucker, and it was Art Tucker is Nuts. Okay? And if y'all had known him, you would agree with it. Okay? I looked at it, and as everybody else is going, okay, that works good for us, but what are we going to teach our students? Well, as I was sitting there on it and trying to remember, that I came up with a teacher is nuts. And y'all can remember that one. Maybe you don't have me as nuts, but you've had some teacher somewhere along the way that was crazy, right? Probably more than one. And you may have one or more of them now. Whether you put me into that category, that's your business, okay? But that gives you something you can remember that one from. And that's where I've remembered that one from since, is that a teacher is nuts. And as it is, I also remember the name of the guy that taught me my first 4 Cisco classes, because of him telling us that one. I couldn't tell you some of the other people I've had teach me on some stuff. There's a few I can't remember, but that one I can still remember his name because of that. Okay? So that gives you a mnemonic for remembering all that. But that's working from the top down, whereas where I told you about programmers do not throw sausage pizza all the way, that's working from bottom up. Just remember the order they come in, okay? Again, when you go to take the test, remember all taking the test, I said you can have a blank piece of paper there to take the test with, and that you can write on and everything. Just destroy it afterwards. If you go to take a certification test, they will allow you to have, they'll either give you blank paper to write on, or they may give you a marker board and a marker to sit there and keep little notes on. But then when you finish the certification test, you have to give up that paper or your notes that you've done in there, and you don't get to keep it, okay? But you can sit there and write notes, and writing notes down as you take the test on a lot of these tests can be helpful to you, because as you get to a later question, you go, wait a minute, I remember something from an earlier question that gives me the answer to this one. Or in the case of this, on this chapter's test, and when you get to the final, I definitely put down there myself a note. Maybe not spell them all out right here, but at least write down what the beginning letter is, so that you can then, when they say, which layer is layer 3, you'll not be able to go, okay, it's network. Because otherwise, it's the 15th question on the chapter test, or it's the 45th question on the final exam. And you get the question of, what is the 4th layer of the OSI model? And you've been looking at everything else on that test, and you all of a sudden go, I can't remember my layers at all at this point. And then you get them all mixed up in your head. But this is a bunch of alphabet soup we got here. Okay? Because after all, I threw you the O and the I and the S, and told you, depending on what order we put them in, they mean 3 different things. Okay? I told you FTP, you're going to find that one popping up, and you got to know which FTP are they talking about. ATM, what's ATM for you right now?
Automated teller machine.
Automated teller machines, where we go get money out of, right? You're also going to find, as you go along through networking, that that is a protocol used out there, which actually is used by the ATM machines. That stands for something totally different. Okay? And you can read some technical articles out there with talking about ATM machines and get confused reading it, because they'll throw ATM both ways through the article, and you got to sit there and stop and think, which ATM were they talking about, the machine or the protocol at that point? Okay? And can get confusing at times. But this is going to be exactly the same as that one. It's just it's going to change, combine some layers and changed a few names.
So this has always confused me, but what you're saying is that's not really anything to do with how anything communicates or protocols or anything like that. It's just like, here's how we see it versus how we see it. It's the same thing, it's just a different way of, this is what the way we see it.
The protocols are all going to work in here because we're going to put protocols on various layers. So that your HTTP is looking up here. We're going to have the IP and IP protocols.
But what I'm saying is they're both looking at the same thing, they're just seeing it differently.
Yeah, two different views of the same.
Two different views of the same thing.
Okay, yeah.
This, looking at how it's really handled, and here's their view of how it gets handled through the whole thing. And that they took two different views of how to look at it. Okay? But you've got to picture how it's going through it, okay? And picture back to the post office line. I got certified as a Microsoft Certified System Engineer, MCSE, which is Microsoft's premier certification, okay? Without really understanding this, I knew what the layers were, but I had the hardest time trying to remember what they were because I didn't really know what occurred on. The books from the Microsoft viewpoint just told you what the layers were, and then you needed to know the layers, and that stuff passed down through it, but they didn't really describe out what happened on the layers and do any relation on it. And when I went to take my certification, the first certification test for that one, it was heavily asking me about this. I had the hardest time sitting there trying to remember them because I had no idea how they really fit together. When I took this class, it fell in place. Cisco described it a whole lot better and showed on it. And your online curriculum goes further on that, where they take you through the simulations and stuff, showing you stuff traveling through, and you get the idea. And when it got described to me, think of it like how the post office works, made total sense, because we actually do the same type thing to mail a letter through the post office. Start off with the letter, you put it in an envelope, you put the name of the person you're sending it to on it. You then put their physical address on it, which you may have to look up differently. Because I know I'm sending it to John, but I don't remember what his physical address is, so I have to go look up in my address book to see what John's actual address is. And then I take it to the post office and drop it in the slot at the post office. When it gets to the other end, they figure out where his street is, what city it goes to, get it to the right city, then they take it to the right street, to the right house on that street, and leave it in the mailbox there. When it gets pulled out of the mailbox, assuming John's sharing a house with several other people, that they then look at it and see which person does it belong to in the house. If it was a bill I was sending to John, everybody else is going to pass it off real quick. Where I'm sending John a check, everybody's going to claim that they're John, right? But at that point, you determine, back up to there, you determine who does it belong to, hand the envelope to them, and then John's got the envelope, he opens it, and then pulls the letter out and actually sees, what did I send him? And it was $1 million check they were all arguing on, thinking it was a bill, and they handed it to John because he was the one willing to take it after all. And they're all mad at him now. $1 million checks in the mail, I don't know when you'll get it.
You might not see me Tuesday.
Huh?
If I got $1 million check, I may not be bad.
So if he doesn't show back up in class, y'all may want to become friends with me, but I got to figure out how in the world did I send him $1 million check. Because he'll be back within a day or so later when it bounces all over the place on him. It may take him a few months to come back, because by the time all those bill collectors and everybody comes and repossesses it and throws them in jail and everything before he gets back. Did y'all follow on that? Does that help make some more sense out of it? I hope it helps on it. Okay? and study the stuff that's out there. The other part is, I have got for you a chart sitting there in the chapter also that you can print out. That's both models, compare them, and we're going to put devices and stuff, and we'll talk more about that as we go along through. That summarizes all of this together in one chart. Okay? So that's there too for you. Any questions on it? Either I apparently have been really clear, or I have totally confused y'all, and y'all have no idea in the world what to ask. All right, so do study on it. You do have a test on it by Monday. Okay?
Next Monday?
Should be.
It's a week Monday.
Yeah.
A week.
It's a week Monday, yeah, we'll be back Tuesday, and then, but not next Thursday, and then I think the test is.
So this chapter 3 is not due till the 13th? It's not due till the 13th?
13th, yeah. right.
Okay, that's good.
Okay.
All right, so next Tuesday, we'll review slightly on this again, and then we'll touch on what else they mentioned in the chapter. I thought we didn't have another day to work with it, because I knew we were missing next Thursday.
And we're gonna cover this a lot more later, and I got.
And then, like I say, we're going to spend, when we go to the next chapter, we're going to spend a whole chapter on layer 1. We're going to spend a whole chapter on data link web. We're going to spend 2 or 3 chapters on the network web. We've got a chapter on this, and these are in 1 or 2 chapters total combined. There's not much on these numbers. All you see over here is been put it in one layer there. So by the time you get to the end of the course, you'll have it down. Okay? But it may not be totally clear right now, but hopefully you at least can picture somewhat of what this is. It's not just knowing those 7 words, but some idea of what UV World is doing. But we're going to get into the details of it as we go on through the book. That's where the book goes from here. It's looking at the details of each way. Okay? And we'll see which protocols, back to what John was saying a moment ago, we're going to see what protocols work on each layer as we go also. So on this layer, the Ethernet protocol is going to be there, and that's about it. We're going to do, and some other physical type, and the wireless protocol down here. Doesn't deal with those at all, does it? Because this is just dealing with how do we put it out there. Okay? Good. And it's past time, and I got to get to lunch in downtown for a meeting.
I was going to ask you a question. I got email from this morning about those signs I submitted.
Okay.
About those signs I submitted to you yesterday. Why not send them to you through the Dropbox? That sent through the email.
You sent through email.
Really? I could have sworn I put that.
That's where I responded back to you.
So
put them-
fix that real quick.
Are you
Talking about chapter 2 assignment, the lab.
He's in the other class.
I submitted the chapter 2 assignment, like I went to assignments and the little green thing, I clicked on it and then
You
uploaded
submitted
it.
it there? Okay.
But it's not showing up on my Netacad.
Okay, it's not going to show in Netacad.
It's not?
It's not going to show in Netacad until I physically transfer. So right now, your lab grades are going to show in Blackboard, your test grades are going to show in Netacad, and not the other one until I get a chance to. Because I have to
I
manually
got you.
transfer them from one to the other.
Yeah, I just didn't know if it
Okay.
didn't go on right or something. No.
I'm busy with everything else and haven't even touched that.
So this is on right. We only have it.